We're going to get started with our third session, MARC21, and I'm not going to say that full title. I'll let them do it. With Crystal Uragi and Laura Ackerman. Crystal is currently Crystal is currently the metadata librarian and co-interim head of metadata and cataloging initiatives unit at the University of Washington Libraries. Her work focuses on link open data, identity management, and cataloging. She has led the MARC21 Bibliographic LRM, RDA, RDF mapping and conversion projects for several years. Laura is a project manager in library technology and digital strategies at Emory University and has been involved in linked data pilot activities at Emory and several professional groups, including IGELU, ELUNA, linked open data community of practice working groups, and LD4 discovery affinity group, in addition to the MARC2 RDA mapping projects. The floor is yours, ladies.
You. All right, so hello, I'm Crystal, and I'll be presenting today alongside Laura Ackerman from Emory about phase 1 of the MARC21 Bibliographic to LRM RDA RDF mapping and conversion project. We'll start with an overview of our rationale and scope for phase 1 of the project, a bit about our team and expected deliverables for September. Then we'll highlight some major challenges we've encountered over the past few years, including entity recognition and URI minting, our data model for identifiers, our approach to reusing identifiers from non-RDA sources, treatment of non-RDA entities such as topical subjects and other concepts, and identifying and relating agents to resources. We'll close with our vision for phase 2 scope deliverables and some opportunities for participation. The library metadata community has been working diligently towards linked data implementation for over a decade. We share goals of increasing our ability to share entity-based descriptions across communities, developing high-quality structured metadata for machine querying, integrating our data into the semantic web systems and services, and improving contextualization and discoverability for our users. Linked data's potential for libraries can be realized if we have interoperable data models, shared ontologies, or ones which can be easily crosswalked, common string encoding schemes, mappings from legacy data, and the ability to conceptualize our legacy MARC21 data as entity-based description sets. The IFLA, LRM, and RDA user communities need legacy data converted to linked open data, which is consistent with our data model as we move into official RDA implementation. Our project set out to supply a large corpus of such data and to provide open tools for others in our community to convert their legacy data to the LRM, RDA, RDF ontology. The first phase of the project began in 2021 and will wrap up this September. Our primary goals are to create an open source, robust mapping between MARC21 bibliographic data and LRM, RDA, RDF, to move from record-based representation to entity-based metadata by identifying, relating, and describing appropriate RDA entities from legacy data, to create a corresponding open source transformation tool using XSLT, and to publish a large sample data set of transformed legacy MARC21 data for testing and experimentation. Our secondary goals are to provide feedback to the RSC and PCC on their documentation and policies, maintain the mapping and transformation tool as both the MARC21 Bibliographic Standard and the RDA ontology and vocabularies evolve, and to maintain clear documentation to facilitate wide adoption of LRM, RDA, RDF. Phase 1 has been scoped to include MARC21 fields considered core in the PCC Bibliographic Standard Record, or BSR. We've excluded diachronic works and have worked on rudimentary treatment of some types of aggregate. We build on these during future phases. We've distinguished between non-aggregate, parallel aggregates, collection aggregates, and diachronic works, and have included non-aggregates, parallel aggregates, and augmentation aggregates in our transformation for phase 1. We'll address collection, aggregates, and diachronic works during phase 2. We've also done very rudimentary entity deduplication and plan to approach this more thoroughly during phase 2. Our goals and scope have been very ambitious because our work has not received outside funding support and has been done entirely by volunteers. My role has evolved from project manager to project supervisor to project co-supervisor and mapping lead, and Cypress Payne has evolved from a student transformation contributor to project co-supervisor and transformation lead. We've received a huge amount of guidance and support from Deborah Fritz, Gordon Dunsire, and Adam Schiff, and Laura Ackerman, Sita Bagwandan, Eb Cardis, Jenping Lee, Chunghae Lee, and Sophia Zapanidu have contributed countless hours to the mapping work so far. Tynan Chalanor, Sarah Collins, Matthew Hill, and Abignia Rajapu have joined the project recently to take the transformation work to the finish line. The project has also benefited from contributions by Theodora Gerontakos, our former project supervisor and transformation team lead, Zhuo Pan, Penny Sun, Benjamin Riesenberg, Doreen Chen, Sarah Rushka, Yingshan Wang, Melissa Morgan, Aaron Grant, and Alice Chung. This international team has done incredible work, and I really appreciate it. The deliverables we expect to publish in September as a GitHub release will include README files at multiple levels to guide use and interpretation. We'll have XSLT style sheets with the transformation code ready, along with accompanying documentation to guide use. The code will include our initial treatment of select aggregate and of reproduction. We've also included some initial guidelines for post-processing the data. We'll publish CSV files representing our most up-to-date mapping of MARC21 bibliographic data to LRM, RDA, RDF, and we'll publish a large sample output data set. We'll make vocabularies and metadata properties we've published at the UW libraries available and package selections from our GitHub wiki, issues, and discussion. We'll include an edited version of our decisions index, which summarizes important decisions the group has made so far. And we'll publish our mapping methodology, an approved list of URIs for sources of vocabularies and authorized access points, a sample of a wiki-based cloud server for experimentation with RDA bibliographic data, and we will send feedback to the PCC and RSE jointly. We welcome feedback on our deliverables from the community. We have templates for issues in our GitHub repository for reporting bugs with the code or more general feedback. And we also have a feedback form at this bit.ly link or the QR code they go into. So now we'll talk about some of the major challenges we've faced during phase 1. And this is not by any means an exhaustive list. You can check out our GitHub for more details on everything else. Our first transformation hurdle was figuring out how to recognize distinct entities with accuracy and legacy data, and to reliably mint URIs for them when they didn't exist already. This is the case most of the time because MARC21 is record-based and usually only implies the existence of entities such as works, expressions, manifestations, and items. Here's an example of an input record from a recent test data set. It's a report from a research panel on aquaculture from the late 70s, and this was cataloged before the existence of the semantic web. So the idea of a linked data entity just didn't even exist. We've got some 3XX fields though, which OCLC automatically put into things. And we've got subjects and agent. It's a pretty average record in our legacy data for a non-aggregate resource. There isn't anything here that says explicitly that it represents a work, expression, manifestation, item, several concepts, and agents. But human catalogers trained in RDA can pick out these types of entities and describe them based on the information you see here. The first thing we try to figure out when we run our transformation is whether a MARC record represents an aggregate. We use logical pattern matching written by Deborah Fritz and tested by the rest of the team to detect aggregate types using code written by Tynan and Cypress. Next, we need to determine which RDA entities are being alluded to by the MARC record. We use patterns of conditions to determine how many entities are being described and how they need to be shaped in RDA, RDF. Here are some logical patterns we used to detect aggregate. Taken on their own, each pattern does not capture all of a certain type of aggregate coming into the transform. As a group, though, they do a really good job of eliminating possibilities and putting records into the correct categories. And here's our XSLT implementing one of the patterns. This code in particular helps detect augmentation aggregates by testing 500. We've done some rudimentary entity deduplication during phase 1, which helps demonstrate the power of RDA to express relationships between linked data entities. We've approached URI minting using concatenated access points for each entity type. This way, we create unique URIs for entities consistently and deduplicate multiple descriptions of the same entity. This approach is going to be refined a lot in phase 2 as it is error prone, but it does help us to demonstrate relationships. Once we've identified a MARC record entities and minted URIs for them, we're ready to extract descriptive elements from MARC21 and assign them to the correct RDA entities. Mappers identify conditions in MARC21 to determine which RDA elements correspond to what entities and give examples of what the output ought to look like. And then the transformation team writes XSL style sheets according to the mapping conditions. They use XSL modes to call appropriate templates for each entity. Here are some of our modes. We have different set of templates that we call for works, serial works, aggregated work, augmentation aggregate, manifestations and original manifestations in the case of reproductions, and so on. Coders call templates with the correct mode to create RDF description sets for each entity. Here's some of that in action. Checking our test output is a big part of our process. Outputs can be viewed as raw code or uploaded into RDA in many metadata formats, or RIM. This is a tool authored by Deborah and Richard Fritz for creating and editing data compliant with RDA. RIMF is really helpful for visualizing data in a more human-readable way, and we're using it to show you examples today. Version 6 has been updated by the MARC of Quality for official RDA and is now available for free download. Here's how our entities are all coming together in RIM. The example record I showed you for the 1979 panel on aquaculture is represented by an RDA work and expression. We have URIs and description sets for each entity in RDF. You can see that the transformation mints URIs with the type of entity first, followed by a hash mark, and then a concatenated access point. We build our access points differently for each type of entity to avoid duplication between variations of works, expressions, and manifestations. Entities coming from the same MARC records are related to one another using appropriate RDA, which is working. Here's the manifestation description set. Since MARC records emphasize manifestation level description, these are frequently the most detailed. We've got a link to the expression manifested and a statement about illustrative content pointing to a vocabulary we published at the UW libraries. We have a supplementary content note, a place of publication from the 264, and a carrier type. We've normalized as many vocabularies which look like official RDA but are not, such as id.loc carrier types, to RDA values as we can. This volume was from the Library of Congress vocabulary, but has been changed to the RDA value vocabulary instead. We have a place of manifestation from the 008 and transcribed statements surrounding the title proper from the 245 field. In addition to taking pieces of the 260 or 264 fields as values of separate elements, we've supplied the entire publication statement as well. And this helps to associate locations, publisher names, and other values when 260 or 264 statements include duplicate subfields, several kind of publisher statements in one, for instance. We've minted some agents and provided an access point, and we also have an additional identifier here. All these elements were called using the manifestation mode. So Laura is going to take it from here to talk further about identifiers, non-RDA entities, and agents.
Thank you, Crystal. You can go on to the next slide. So talking about identifier reuse and data modeling, there are a lot of identifiers in MARC in various places, and so we don't have time to go over all of them. So I selected just to focus on the subjects in this record, some of which are coming from identifier fields and others where we have created identifiers. And not all subject properties are going to come from your 6xx fields. And not every 6xx field is a subject. Next slide, please. So this is a RIMF output of the subjects and the mapping from the fields in the previous slide. And you can see that we have a variety of transform types. So in some cases, we are actually constructing an IRI that fits in with the schematic of an external linked data source, such as id.worldcat.org, id.loc.gov. Okay. We were able to take the contents of a subfield in the field and map it and create an IRI that goes directly to some linked data. This is preferred. Then we have some that have place entity elements as the object of our property, subject place. And I'll talk about those next. And then, let's see, I don't see it, may have gone off the bottom. But we have, category of work. All right, so 655, which is form and genre, actually gets mapped to category of work in RDA. Next slide, please. So I wanted to focus a little bit on these subject place properties. So when a subject is a place, we can use the subject place property. Same thing with if the subject is a person, corporate body, or work. And these are really, there's some variation in these mappings. So I think the first one, we have an extra mapping when there is a 651 geographic MARC tag with multiple subfields. We have an additional mapping just for subfield A as a subject place. And I think the thinking was we don't have the granularity for subject headings in RDA that we have in MARC, and it might be useful for indexing to be able to identify specifically the places. And I'll show you a little bit later what we do with headings that have multiple subfields. Okay. There's a geographic classification code that is mapped to subject place. And there's a geographic area code that's mapped to subject place. And for that one, we just created a URI. But from the other one, I don't know. That one might need a little attention and maybe some more context. What scheme is it in? Because a 4-digit number by itself doesn't tell you very much. So I learned some things from looking at this example, and I think we're going to learn more now that we are in the phase of looking at whole records and being able to compare the outputs from various mappings. I won't say how much of phase 2 might be taken up with revisiting some of our decisions, maybe, or seeing the effect of them. But that should be part of the project, and we probably won't catch everything before the release in September. Next slide, please. This is out of order. Next slide. Okay, there's good. I don't know how that happened, but this is a table of approved URIs. It was assembled by Penny Sun under the guidance of Gordon Dunsire and with input from all the members of the working group. And it shows different types of URIs. So we make a decision about whether we can use a URI as an identifier for the object of a triple or not, based on how closely its definition fits with the type of object that's the range of that property. And so we have, this is just a sample of a pretty substantial table. Some were approved and some were not. So for names and titles, LCNACO authorities for people may also include non-human person entities. So there's a divergence with RDA definitions that may be something that an agreement can be come to later with the addition of information in the authorities, but for right now, we can't map them. And ORCID, we had some comments about, or questions about how well it mapped, but we decided to approve it. So next slide, I think that, okay, we're ready for non-RDA entities. There are probably some non-RDA entities elsewhere in the record, but I think a large number of them are in the subject area. So for subjects that are topical, that are not another kind of RDA entity, like a person, there is no RDA entity type for a concept or a topic. So we decided to create URIs for them. If we didn't have an approved URI we could use from the MARC, create URIs for the subject headings of whatever type and brief SCOS concept descriptions. Next slide. Next. Yes. Okay, so this is a diagram from Gordon Dunsire simplifying sort of how that works. We create the SCOS concept and use some of the properties of SCOS concepts, such as has notation, may have an alternate label. In this case, I don't know that we need an alternate label, but it could be useful, and the scheme that it is in. And in the next slide, you can see an example of a classification number, an LC classification, and shows the scheme, and also an 650 LC subject heading, and the scheme that it's in. Okay, so you will be seeing a lot of those in our input, because many of these kinds of fields don't have IRIs at this point. Next. Okay, and finally, agents and relationships. Next. So RDA specifies properties to establish relationships between works, WEMI, content, and persons, corporate bodies or families, or any other kind of agent. If present, a MARC, relator term, or subfield 4 relator code can, in most cases, be translated into equivalent RDA properties. Next slide. So, for example, just captures the MARC fields that get translated here, and you can see there's quite a few row codes for relationships. And this is the RIMF work output. And it has some properties. So DRT is director person. Okay, because it's in a 700, which we assume to be a person, and DRT is director. That's a good mapping. But not all of these relationships are mapped here. So, and what happened to Paul Herlinger? Next slide. Okay, some of these properties are actually relationships at the expression level, such as narrator person or host person for this video. And there's Paul Herlinger. So next is the table that we use. And I believe this table was one of the areas where Deborah Fritz helped us a lot by leading the effort to create this table and mapping the codes and subfield E relator terms to RDA properties. This saved us an enormous amount of work in the creation of mappings and also for the coding. So I'm just giving a small slice of all the areas of decision, especially related to aggregates, etc. We'll leave that for maybe another time, but it's too wide to put into a slide. But I'm just pointing out some codes that have been translated to RDA, and the one at the end, which is patron, does not have an RDA equivalent. And so the nearest that we can map it to is related person of work. So it's not going to be 100%. Next.
2-minute warning.
Be really fast with talking about phase 2. So our scope for phase 2 will include MARC21 fields recommended rather than core in the BSR and take on the CSR as well. We're going to get more sophisticated with entity deduplication and feature more advanced treatments of aggregates and reproduction. We're going to process all resources with appropriate treatment for aggregates and diachronic works. We really look forward to getting some feedback after publishing our phase 1 results and plan to update our code and mapping during phase 2. We'll also consider requests to map additional MARC21 fields that are not identified as core or recommended by the BSR or CSR. Our deliverables are going to take a pretty similar form to the ones in phase 1. We'll deliver them via a GitHub release. And then, as I mentioned earlier, we're a volunteer-run project, and we can use any help we can get. So if you'd like to get involved, we could use additional volunteers to help with mapping or the transformation, help with writing grant proposals to support more complex aspects of the work, and feedback on our mappings, code, and output data. And then here's the slide for submitting feedback again. The GitHub issues and feedback form will remain consistent between phases.